An object moves along the x-axis so that its position at any time t is greater than 0 is given by x of t is equal to cosine of t squared plus 1. Find the velocity of the object as a function of t. So, I know that given a position function, in order to find the velocity function, I need to take the derivative. So I'm going to go ahead and I'm going to take the derivative of x of t. So the main thing that I have going on here is I have cosine of something. That's my main function. So I'm going to go ahead and I'm going to take derivative of cosine of t squared plus 1. So derivative of cosine is negative sine. And this is the angle. And then I need to remember to use the chain rule and multiply by the derivative of the inside function. So the derivative of t squared is 2t, and the derivative of 1 is 0. So my final answer would be negative 2t sine of t squared plus 1. Again, notice that I'm taking the derivative of the main function, or the outer function, keeping the inner function inside of it, and then I'm multiplying by the derivative of the inner function. Let's look at example 3. I'm going to have to differentiate, that is, take the derivative, of sine of x squared plus e to the x with respect to x. So again, my outer function in this case is sine, and my inner function is x squared plus e to the x. So I'm going to go ahead and take derivative of the outer function. Derivative of sine is cosine. And then I'm going to multiply it by the derivative of the inside function. The derivative of the inside function is 2x plus e to the x. And there's not much that can be done here with this, other than perhaps you want to put this in the front. It's up to you and how you like to view it. Example 4. The main function that we have going on here is the fact we have e to the power of some function. And so when we go to take derivative, the derivative of e to the some function is still e to the some function, but I need to multiply by the derivative of the exponent. So the derivative of cosine is negative sine. Again, purely preference, but if you would like, you can put the sine x in the front and the e to the cosine x after. It's purely up to you. Find the derivative of g to the x equals tangent of 5 minus sine of 2t. Well, I'm not going to panic. There's a lot of stuff going on here, but I know that the main function we're talking about, the outer function, is tangent. So I'm going to start off by taking derivative of tangent, which is secant squared. Notice how the angle stays the same. So this is the derivative of the outer. And then I'm going to go ahead and take derivative of the inner, which is this part of it. So my derivative of 5 is 0, and my derivative of sine of 2t is cosine of 2t. But here's a problem. When I go to take derivative of sine of 2t, that wasn't just derivative of sine of an angle. It was derivative of sine of a function of t. So I need to look at this as like an inside of the inside here. I also need to multiply by derivative of that, which is 2. So the inner portion of this problem had an inside of that as well. So not only did I need derivative of the inner function, but I also needed the derivative of the inside of the inner function. There are two problems for you to try on the next slide.